All right, so if you've ever used Stellar, you know what it's great at, right? It's incredibly fast, super low cost, and perfect for simple stuff. But what if we could give those operations a brain? Well, that's exactly what we're going to do today. We are going way beyond basic payments and diving headfirst into the world of smart contracts. My goal is to take you from knowing nothing to deploying your very first contract on Stellar. Let's do it.
So let's start with a kind of a wild idea. What if money could actually think? I mean, really think about that. Imagine a payment that only goes through after a delivery is confirmed, or an insurance policy that pays out automatically the second your flight is delayed. No phone calls, no forms, no middlemen. That, right there, is the magic of smart contracts. It's not just about sending value anymore. It's about making value intelligent.
This slide really just lays it all out. On the left, that's the Stellar we've known for years. It's like a perfectly efficient assembly line. It does a few things, and it does them incredibly well. But on the right, that's the future. That's a dynamic, programmable workshop where you can build literally anything, from crowdfunding platforms to complex financial instruments. This isn't just an update, it's a completely new dimension for the entire network.
And this new frontier on Stellar has a name, Soroban. It's the powerful engine that's bringing all this smart contract capability to life. And the cool thing is, it was designed from the ground up using some seriously modern and powerful tech.
So how does this all work under the hood? Well, think of it like this. You write the actual logic, the blueprint for your contract, in a language called Rust, which is famous for being incredibly safe. Then, that blueprint gets compiled into something called WebAssembly, or Wasm for short. Wasm is like a universal language that virtually any machine can understand, and it runs in a super secure, sandboxed environment. This combination gives you the best of both worlds, rock-solid safety and blazing fast performance.
Now you're probably thinking, oh great, another smart contract platform. I get it. But Soroban is different because it was built with the benefit of hindsight, learning from all the challenges and pitfalls of earlier platforms. The entire philosophy here is to be safer and more developer-friendly from day one. And this is where you can really see that design philosophy come to life. I mean, compared to Ethereum, just switching to Rust is a huge deal for security. But look at the other details. Gas fees are predictable. No more wild guesses about your transaction costs. Re-entrancy attacks, that nasty bug that's drained millions from other platforms, are structurally impossible. The design just doesn't allow for it. And you get a testing framework built right in. These aren't just minor features. They are direct solutions to some of the biggest headaches in blockchain development today.
Okay, let's talk about the elephant in the room. Rust. I know, it has a reputation for being a little challenging to learn. But there is a very good reason it was chosen for something as mission-critical as smart contracts, where your money is on the line and security is absolutely everything.
Here's the deal with Rust. Think of its compiler as the strictest, most paranoid security guard you've ever met. Before your code is even allowed to be compiled, that compiler meticulously checks it for whole categories of common dangerous bugs, the kind of memory errors that have plagued developers for decades. It's like having a world-class security audit run automatically, for free, every single time you build your code. Your contracts are just fundamentally safer from the very start.
All right, enough theory. Let's get our hands dirty, shall we? It's time to go from concepts to actual code and get your very first contract up and running on the testnet. And I think you'll be surprised at how quick and straightforward it really is.
First, there's a little one-time setup. It's literally just 4 commands in your terminal. You'll install Rust with Rust Up, add the special WebAssembly target, grab the Stellar command line tool, and then create a new project. That's it. Once you do this, you're all set to start writing smart contracts.
As you start looking at Soroban code, you're going to see this thing everywhere, @contract_impl. Don't let the weird syntax throw you. You can just think of this as a big signpost that says, hey network, the public functions that people can actually call start here. It's simply how you define the public-facing part of your contract.
And the whole workflow, the lifecycle, is just as simple. It's a 3-step dance. First, you build your contract, which turns your Rust code into that Wasm file. Then you deploy that file to the network, which gives it a permanent address. And finally, you invoke functions at that address. Build, deploy, invoke. It's a clean, repeatable process.
Hello World is a great first step, for sure. But now let's look at some real-world patterns. These are the foundational building blocks you're going to use over and over again to create actual decentralized applications, or dApps.
So let's start with a super simple counter. It sounds basic, but it teaches us 4 absolutely essential concepts. 1, we store the count in instance storage, perfect for settings that rarely change. 2, we set an admin who has special powers. 3, we use require auth to make sure only the admin can use those powers. This is a critical security pattern. And 4, we publish an event every time the counter changes, so the outside world can listen and react.
Okay, now let's level up and use those same concepts in a classic escrow contract. This is a perfect real-world use case. It holds funds between different people. Just like our counter, it uses require auth to make sure only the right person can approve or refund the deal. But it also introduces 2 new things: how to interact with and transfer tokens, and how to manage the contract's state, moving it cleanly from pending to either released or refunded.
So, you've seen the basics, you've seen some patterns. Now it's time to really level up your game with a few essential concepts that every single serious Soroban developer needs to have in their back pocket. This is the Pro Toolkit.
One of the most important concepts in Soroban is that not all data is treated the same. You have 3 types of storage. Think of it this way. Instant storage is for set it and forget it data, like your contract's admin address. Persistent storage is for long-term data that needs to stick around, like user balances. And temporary storage is for data that has a built-in expiration date, perfect for things like rate limiting. Choosing the right one is key to building efficient and cost-effective contracts.
Of course, your contract doesn't exist in a bubble. Your front-end app needs to talk to it. From JavaScript, the flow is pretty logical. You connect to a server, you build the transaction, and then, and this is by far the most important part, you simulate it. Only after the simulation is successful do you sign it and submit it to the network. I really want to double down on that simulation step, because if you take away only one thing from this whole section, it's this. There is one golden rule, one thing you absolutely must do every time you submit a transaction.
And here it is. Please burn this into your brain. Always run simulateTransaction before you submit anything for real. Why? It's simple. It does 2 critical things for you. First, it tells you the exact fee you need to include. Second, it tells you if the transaction is even going to work. This single step prevents almost all failed transactions and wasted fees. It's not optional, it's essential.
And before you even think about putting a contract on the mainnet with real value, you need a pre-flight checklist. Just like a pilot, go through it every time. Is every important function protected by authentication? Are you using safe math functions to avoid overflows? Did you pick the most efficient storage type? Do all your tests pass? This little checklist will save you a world of pain.
Okay, wow, we have covered a lot of ground today. So to help pull it all together, let's condense the most important stuff into a simple, practical cheat sheet that you can use when you start building your own amazing things.
And here it is, your Soroban Quick Reference Guide. You've got the commands to build, deploy, and call your contracts. You've got the key patterns for security and for your front end. And of course, the command to run those all-important tests. Go ahead, screenshot this, save it somewhere handy. This is your day 1 guide to building on Soroban.
So we started today with a big idea, this idea of programmable money. And we went all the way from just talking about it to actually deploying a contract. You now have the fundamental knowledge and the tools to build secure, efficient, and really powerful applications on Stellar. So the only question I have left for you is this. You've deployed your first contract. What amazing problem are you going to solve next?